Okay, here's page 11 of our final exam review. This will be my second attempt at this video as I had the issue yesterday. Alright, so determine which ordered pair are part of the solution set for each inequality. We have the inequality 3x plus y is greater than or equal to 6, and we have a total of 4 points that we're supposed to figure out whether or not they're part of the solution set. So the simplest way, or the easiest way to keep track here, would be to make yourself a little bit of a table. And what we're going to do basically is we're going to test these points out to see whether or not they are true or false. So we're going to take those points and we're going to plug them into the inequality and see whether or not the inequality is true. So looking at the answers here, notice how 4-3 is in all 3 out of the 4 answers. So testing it should give us some information on the actual answer. So we plug in 4 for x and 3 for y, and we check to see whether or not that is a true statement. So we'd feed 3 times 4 plus 3 to the calculator, which would be 15, is greater than or equal to 6. That is a true statement. Now that means that 4-3 should be part of the solution set. So since it's not part of the solution set for B, we can eliminate answer choice B. Now looking at what's left, 2 of them have 3, -3. So if we test that point next, that might be enough information for us to actually finish the entire problem. So we're going to check that one next. We're going to do 3 times 3 plus -3. And again, we're checking to see, is that greater than or equal to 6? Well, 3 times 3 is 9. 9 minus 3 is 6. So we have to ask ourselves, is that a true statement? And the answer is yes, that is a true statement. So 3, -3 should be part of the solution set, which means A is not the answer because it doesn't contain 3, -3. Now looking at what's left, the only point that's different here is -2, 4, so we should check that one next. And really, if we check the others, it will still get to the right answer eventually. So it doesn't much matter which point we test. We can just check them in order if you want. Not real sure why I put that extra set of parentheses in there, so I'm going to remove those before they confuse somebody. So again, we're going to plug in -2 for x, and we're going to plug in 4 for y, and we're checking to see whether or not that number is greater than or equal to x. Well, that's -6 plus 4, which would be -2. That is a false statement, which means this point should not be in the solution set, which means that D cannot be the correct answer, and leaves only B. Now, if you were to check the last point, which you don't have to because it's a multiple choice question and we've already figured out the answer, we would do 3 times -5 plus -3, checking to see whether or not that is part of the solution set. That's -15 plus -3, which is -18. That would be false as well, which means that point should not be in the solution set. So our solution set should consist of only 4, 3, and 3, -3, which is answer choice C. Alright, budgeting. Sachi found a used bookstore that sells pre-owned DVDs and CDs. DVDs cost $9 each, CDs cost $7 each. Sachi can spend no more than $35. So if we look here, there are 2 items, which we will refer to hereforth as X and Y, being purchased in this situation. So what we do is we attach the cost of X, which would be 9 for each DVD, and the cost of each CD, so 7 times Y, and then we need to figure out what sign to use. No more than is less than or equal to. So that would be is less than or equal to 35. That would be the inequality, and that takes care of the first part of this question. Now, the second part of the question is asking us to check for 2 DVDs and 3 CDs. So we are going to check to see if x equals 2 and y equals 3 is in the solution set, just like we did on the previous problem. So we're going to plug in 2 for x and 3 for y, and we are checking to see whether or not that is a true statement. Well, 9 times 2 is 18, and 7 times 3 is 21. So when I add those together, that would be 39. That is not possible because 39 is not less than or equal to 35. So we would say no, Sachi cannot buy. 2 DVDs and 3 CDs. Or you could just say no. That would be fine too. But you know me, I like to write out an exact answer to my word problems. On to number 55. Number 55 says graph the system of equations and determine whether the solution or the system has no solution, one solution, or infinitely many solutions. If the system has one solution, name it. So, our first equation here I'm going to graph with blue. Keep in mind that when we graph a line in slope-intercept form, the b value, or 2, tells us where to start. It tells us to start at the point 0, 2, the y-intercept. So we'd go to 0, 2, and we'd put a dot. And then the slope value, which is negative 2, can be written as a fraction, negative 2 over 1. And that tells us to start at our point and go down 2, and then right 1 to find another point. So from our starting point, we go down 2, right 1, down 2, right 1, down 2, right 1. Okay, and we can extend that all the way to the bottom. We could also go up 2 and left 1. That has the exact same truth value. So all of those points would be on the first line, and we would graph a solid blue line through those points using our straight edge. All right, the other line I'm going to do with red. Okay, same idea. It's in slope-intercept form. So we have a slope and an intercept. B is negative 4, which tells us that we're going to start at 0, negative 4. So down 4 from the origin. And the slope of 4, which can be written as 4 over 1, is telling us to go up 4 and right 1. So from there we go up 4 and right 1, up 4 and right 1. Could also go down 4 and left 1. So those points would be on the second line, which I will graph in red. Looks like this. Now, as for the solution is where those two graphs intersect. So those graphs intersect at the point 1, 0, which is the solution. So this system has one solution at 1, 0. So what it asked us, how many solutions, and if it's 1, what is it? So there we go. We've answered that question. Let's do another one. Number 56 has the same directions. Now it is a little bit harder because one of the equations is not in slope-intercept form. So we will start with the line y equals 2x minus 3, which is in slope-intercept form. The intercept is negative 3, so we're going to start at 0, negative 3. And the slope is 2, or 2 over 1, which tells us to go up 2 and right 1. So we're going to start at negative 3, up 2, right 1. We could also do down 2 and left 1. So our first line, which is graphed in red, would pass through those points. Now the other line, which we'll do in blue, requires a tiny bit of work because right now it is not in slope-intercept form. So to put it in slope-intercept form, we're going to need to solve for y. So I'm going to flip it around as well. 2y equals 4x minus 6 when I move the 6. And then I need to divide everything by 2, which would give me y equals 2x minus 3. Which means that just like the last one, we're going to start at 0, negative 3. And then we are going to use a slope of 2, which is again 2 over 1, and tells us to go up 2 and right 1. But Mr. Wills, we just did that. You're 100% correct. This is exactly the same line. So you have to ask yourself, well, what does that mean? Well, what that means, once I get this drawn in here, is that we have the same line twice. And if we have the same line twice, that means that every single point on the line is a solution. So we would state that this system has infinite solutions, and that would be our answer. Because again, every point on the line is a solution. And a line is a set, an infinitely large set of points. Is a solutions. Great. Good job. Way to grammar, Wills. Let's get rid of that. There we go. All right. Moving on. Number 57 says use substitution to solve the system of equations. So you'll notice that the first equation is solved for y. So what we're going to do is we're going to take 5x plus 13 and we're going to plug it in for this y. So that will give us 3x minus 6 times, and this is where the 5x plus 13 will be inserted, 5x plus 13 equals negative 24. And we're going to solve that. So we would start by distributing the negative 6, which would give me 3x minus 30x minus, what is that, 78 equals negative 24. We would combine like terms. 3 minus 30 would be negative 27x minus 78 equals negative 24. That becomes a two-step equation, so we would add 78 to each side, which would give us negative 27x equals 54. And then we would divide by negative 27, which would give us x equals negative 2. Now we're not done, because we have x. Now we need to find y. So if x equals negative 2, then y would be 5 times negative 2, because I can plug that into the first equation, plus 13, which would be negative 10 plus 13, so y is 3. Which means my answer is the point negative 2, 3. Let's move on to number 58. All right, this is a word problem, but it's a pretty easy word problem. It says the sum of two numbers is 90. So we don't know what either one of those numbers are. So our two numbers are going to be x and y. Okay? So it says the sum, which is addition, of those two numbers is 90. So x plus y equals 90. Then it goes on to say their difference, which is subtraction, so x minus y is 12. What are the numbers? Guys, that's a system of equations. And not only is it a system of equations, it is a system of equations that is already set up for elimination. So we simply add those equations together. The y drops out, and we get 2x equals 102. Divide by 2, and we get that the first number, x, is 51. If x is 51, then 51 plus y is 90, because I can plug that right into the first equation for x. Subtract 51 from each side. And we get y equals 39. So we would say the numbers are, it's a word problem, so we should answer the question that was asked. What are the numbers? The numbers are 39 and 51. Should not answer with an ordered pair. Should answer with what are the numbers. There you go. Okay, last problem on the page. Christy has a total of 15 pieces of fruit, all bananas and apples. So bananas is going to be one of your variables. Let's say that's x, and you can use whatever variable you want. If you'd rather use b and a, go for it. We're going to let x be bananas and a be apples. So they told us they have 15 pieces of fruit. So x plus y is 15. Okay, they also told us what they're worth. Bananas are 13 cents, okay? Apples are 7 cents. So we would say 13x plus 7y equals. Now this is tricky. Notice they're worth $1.59. Well, that's 159 cents, right? So since we wrote the 13 and the 7 in terms of cents, we need to write that amount in cents as well, which would be 159. Now I would consider this to be an elimination problem as well. I would eliminate y by multiplying the entire first equation, and I guess I should write it like this, by negative 7, which would change my system into negative 7x minus 7y equals negative 105 for the first equation. And the second equation would remain 13x plus 7y equals 159. We add those equations together because we have managed to eliminate y. If we do, negative 7 plus 13 is 6x, and negative 105 plus 59 is 54. Divide by 6, and we get x is 9. Then we take that 9 and we plug it in up here in the original first equation. 9 plus y equals 15. Subtract 9, and we get y equals 6. Then we just have to answer the word problem with a word answer. Remember that x is the number of bananas and y is the number of apples. And if it said define the variables, we would have had to have actually stated that, but it didn't, so we don't. It says how many bananas and how many apples? She has, come on computer, there we go. Oh great, that's wonderful. She has 9 bananas and 6 apples. And that does it for page 11.